In the notes page, you were introduced to the concept of projectile motion in oblique form. And you're also introduced to the equations that you can use to solve the questions. In this video, we'll break down a typical projectile motion question that you might come up in tests or exams, and we'll show you how to solve it step by step. And by the end of this video, we hope that you'll have a better understanding of how to approach and solve projectile motion questions. So here's the question we have right now. It says a motorcyclist leaves the ramp at an angle of 50 degrees to the horizontal. The edge of the ramp is 2 meters above the ground, and a pool is located 7.2 meters above the ground. The bike and the rider leave the ramp at a speed of 70 kilometers per hour. Now, we can instantly see that there's a lot of information, and it's really hard to see what is going on. So what we'll do is what everyone should do at the start of any physics question, and that is to draw a diagram. So here's the diagram that relates to the information we're provided. And we can instantly see that this is much easier to look at and is much simpler, and we can just easily see what is going on. And if you try to relate it to the information, you can easily see that the rider leaves the ramp at 50 degrees over here, and to the horizontal, the ramp is 2 meters above the ground, a pool is located 7.2 meters, and the rider leaves at 70 kilometers per hour. So there's a simple diagram. So now let's look at the first question. The first question says, calculate the vertical component of the motorcyclist's velocity on liftoff. Now, from the notes page, we should already know that to calculate the vertical component of any vector in any physics problem, you can easily just multiply it by cosine theta, where theta is the angle between the vector and the horizontal. So that's simply what we'll do here. So we'll just do 70 multiplied by cosine. Now our angle here was 50 degrees, so that's what we'll use, 50. And if we punch that into a calculator, we get 44.995 kilometers per hour. But we know that the standard units for physics is meters per second. So to convert from kilometers per hour to meters per second, we'll simply just divide by 3.6. So dividing that by 3.6 gives us 12.50 meters per second. And that simply is our answer. Now, let's look at part B of this question. Part B of this question asks us to calculate the maximum height reached above the ground. So it's basically saying, if you look at our diagram, to find this height, how much is that from the ground? Now, that's a bit hard to look at, but what we can remind ourselves is that whenever a question asks us to find the maximum height of something, whenever an object is at its maximum height, at that instantaneous time, it's not moving anywhere. Its velocity is neither going up, nor is it going down. So that means that the vertical component of the velocity should be 0 at that maximum height. So we'll use that information. So what we'll do is we'll scan through our equation sheet and see if there's any equation that has displacement or height and also has velocity. So let's look at here. So this is the equations of motion. Well, that's what we're looking at. Okay, so the first one is v equals u plus at. That doesn't have displacement, so we won't use that. The second one is s equals ut plus half at squared. Again, that is kind of useless because it doesn't have velocity or final velocity. And if we look at the next one, v squared equals u squared plus 2as. That makes sense because we have u, which is the initial velocity, which we know is 70. S is what we're trying to find. A is our acceleration due to gravity. And v, we know, again, at the maximum height is 0. So that's the equation that we'll use. So if we go back to our question, we're going to use the v vertical. Remember to put the subscript v so we know that we're talking about the vertical component. Nope, not that. So v vertical squared equals u vertical squared plus 2as, where if we write our variables out here, s is what we're trying to find, v vertical we know is 0, and u vertical is actually what we found in the question before, which is 12.5. And a is negative 9.8, and remember to put our direction, so negative is down. Okay, now plugging that in, so 0 squared equals 12.5 squared plus 2 times negative 9.8 times s. So that means that negative 12.5 squared is simply equals to negative 2 times 9.8 times s. So S is equal to negative 12.5 squared over negative 2 times 9.8. And if we plug that into a calculator, we can easily see the negative cancel out, so we don't need to worry about that. 12.5 squared divided by 2 times 9.8 gives us 7.97 meters. So remember to put our units. So that basically says that this here is 7.97. So that's our breakdown for this question, and hopefully you could see how to break down a very complicated looking physics problem. The first step is to always just draw a diagram, and then from your diagram, whatever question you have, you can just see what variable you have and what variable you don't have. And then you can just scan your equation sheet to find which equation you can use to find the answer. Thank you for watching. My name is Dev, and I am part of a team here at Elucidate, where we're a non-for-profit organization that help young people succeed at school. So if you want to learn more about our course content, then click here. And if you want to know more about us or even support us, then you can click here.